We will now start our journey into sound perception, and we'll talk about frequency and level range of human hearing. So physically, sound can be described by the frequency of a sound wave, here in this scale going from 20 to 20 kilohertz, sound pressure, which is the force of sound on a surface area, and sound intensity, which is the sound power per unit area. The lowest sound pressure possible to hear is approximately 2 times 10 to the power of minus 5 Pascal. It is therefore convenient to express the sound pressure as a logarithmic decibel scale related to this lowest human hearable sound of 2 times 10 to the power of minus 5 Pascal, which is 0 dB. In this picture here, we can see the human hearing area, which is a plane in which audible sounds can be displayed in terms of frequencies with respect to sound pressure and sound intensity. Here we see the limit of damage risk. This is the threshold of pain. Here is where more or less music and speech can be found, and this is the threshold in quiet. So here we have sound pressure level in dB. Here we have sound intensity level. Here we have the sound pressure in Pascal. A human ear can perceive the sounds from approximately 16 Hz up to 20 kHz. The actual hearing area lies between the threshold in quiet towards the limit towards the low levels and the threshold of pain, the limit towards the high levels. The threshold in quiet is a threshold of sound pressure for different frequencies below which a human ear cannot perceive sound. So all this area here, we cannot perceive sound. So that means that below some sound intensity, we will hear nothing. The second important border is the limit of damage risk. Above this sound intensity, we can damage our ears. Thus, for example, in factories where noise reaches 5 dB below of this threshold, the earplugs have to be used by workers in order not to damage the ears. And the third main threshold is the threshold of pain, and between these thresholds lies the hearing area, which corresponds to normal music and normal hearing of sounds. As it was said earlier, the ear canal corresponds to a quarter of the wavelength of frequencies near 4 kHz, and we see here that this region can be easily damaged because of the high ear sensitivity at those frequencies. Also, as we know, with years our hearing abilities becomes lower and lower. It means that the threshold of hearing grows. So for example, whispering, which we could hear when we were 20 years old, at 60 to 70 years we will not hear anymore. And moreover, this threshold is not absolute and varies from different persons at different age. So for example, here we have the hearing threshold of 100 persons with normal hearing for sign tongues. And here we have the 50% curve in the median. We can approximate these curves using this equation here. And we see that the curve changes with age. Here we have the threshold for 20 years old in average, and we see that when we get older, this curve is changing. Here we can see the hearing threshold related to age. So we have here average pure tone audiograms in dB for hearing loss in men and women grouped by their age in decades. So we can take a look here and we see different age groups for male and female and the hearing loss in dB, so the hearing threshold. And we see also here the standard deviation of all participants as a function of frequency, and the parameters age in 10-year groups. at this website here is very interesting that you can make a simple hearing test. So you just read here and you have this. So when you press, you should start from the bottom and then start pressing until you hear some frequencies. And then, for example, when you hear, you stop and it will draw more or less your hearing curve. So this is very interesting to play around.